This is problem 8-10 from section 8.1.1. Describe the possible number of intersections for each of the following pairs of graphs. Sketch a graph for each possibility. So your solution should include all the possibilities and a sketched example for each one. Alright, so part A, we have two different lines. Let's see, they could be parallel, is a possibility, so they never intersect. They could intersect once like this. I'm going to be a little lazy and not put the arrows on the ends. And they could also be the same exact line on top of each other. So for part A, we have 0, 1, and infinitely many intersections. Okay, so that's if they're the same line. They're going to intersect the entire way through the line. Okay. Part B is a line and a parabola. Think about this, they could have a parabola like that, a line down here, so they could never intersect. We could have it touch at the vertex one time right there. We could have it go through like that, so that would be 2 times. Okay? And that's as many ways as we can have this happen. We can't have, even if I change where my parabola, or where my line goes through, let's pick a different color here, even if, if I change it like that, it still is only going through twice. So total I have 0, 1, and 2 times for part B, for a line and a parabola. Part C, 2 parabolas. Alright, let's think. First of all, they could never touch if they're like reflected from each other. They could touch exactly once if they're, oops, that was supposed to touch right here. Maybe they have the same vertex. If I have it maybe like this, that's 2 times. Okay. We can also talk about like sideways parabolas. So say I have one like this, and I have it going through, and I just touch. I can't get my drawing to look very good there. Okay. So now I have it touching. Let me show you here in red. We got 1, 2, 3 spots touching, intersecting. So that was a total of 3. We have 0, 1, 2, 3 so far. I could have a parabola also like this, and it could go through here. It could be a sideways one, or sleeping parabola is what we called it a long time ago. And we had this, so that's 1, 2, 3, 4 different ways of intersection. So we have 0, 1, 2, 3, 4 is our maximum for 2 different parabolas. Okay. Last one for part D wants us to know a parabola and a circle. Okay. Let's figure that out. D. Parabola and a circle. So let's think if they're not touching. I got a circle here. A parabola, it starts like up higher, so that's nothing touching. We could have it touch directly, boop, right there. That was a pretty good one. Right here is 1 time touching. Okay. We could have circle and a parabola. Okay, it's going through, it's touching twice. We could have a parabola touch its vertex down here. So now that's 3 times. Let me show you that. 1, 2, 3 times. And we can have another one as well. If my parabola continues all the way through the circle, now I have 4 times. 1, 2, 3, 4. Okay? And even if I turn my parabola sideways, that's going to be the maximum number. So again, I have 1, 2, 3, 4 ways for part D. Okay, so drawing a picture, make sure you're drawing a picture for these. That really helps to visualize what's appropriate, and answering the number of times it can intersect. And keeping all this in mind for when I'm actually doing graphs and stuff.